AP Calculus AB, section 3.8, page 2. Okay, on page 1, we had just gone through an example to kind of come up with this theorem, but now let's go ahead and write it out. And it starts off, if some point CD is on f of x, so let's just kind of make sure you understand what that means. If CD is on f of x, that means that f of c is equal to d. Then DC is on the inverse, right? If CD is on F, then DC is on the inverse. So this means that F inverse of D is equal to C. Then, so if we have this situation, then F prime at C and F inverse prime at D are reciprocals. I like to write it this way. It's easier for me to think about, although in most textbooks you'll see it written this way. F prime at C is 1 over F inverse prime at D, or even F inverse prime at D is 1 over F prime of C. Either way, it's notation-wise, word-wise, is that those two are reciprocals of each other. This concept is very useful when we cannot actually find the inverse of a function. Alright, let's take a look at this example down here. If f of x is 4x cubed plus 2x, then I want you to find f inverse prime at 6. Well, the first thing that we do is you try to go kind of straightforward. Let's see, if we want the inverse derivative at 6, we could try to find the inverse. Then find its derivative. Then evaluate at 6. All right, let's try that. So first we'll try to find the inverse. So switch the x and the y. X equals 4y cubed plus 2y. And we try and isolate the y. Get only the y's on one side and everything else on the other side. And we're not going to be able to do that. Even if we factor out a y, we could divide by 4y squared plus 2 over to the left, but then we'd have y over here on the right, but we still have y's on the left. Because these y's have different powers, you are not going to be able to solve for y. Oh no, we can't find the inverse. We're in trouble. But don't quit. Don't quit. Try something else. All right, how about our new nifty theorem? All right, so what this says, if we're going to use this new nifty theorem, it's going to say find f prime at C, then take the reciprocal of that. So let's start. F prime of x. All right, f prime of x is going to be 12x squared plus 2. All right, now we want to find f prime at c. Well, what's c? I don't know. But we do know that c comma d is on f of x. And we know that this 6 up here, that's the d value. That's the d value that's coming right back up here. F inverse prime at d, that's what we're looking for. F inverse prime at d. That d is the x value on the inverse, but it's the y value on the function. Let me say that again. This d is the x value on the inverse, but it's the y value on the function. So CD is on f of x, but that's c comma 6 is on f of x. So could we set our f of x equal to 6 and find that? F of c is equal to 6. That means 4c cubed plus 2c equals 6. Can you figure out what c is just by inspection, meaning not having to do anything other than think? 4 times c cubed plus 2 times c equals 6. Yes, c is 1. And we did find that just by inspection. Sometimes you can't figure that out by inspection. You would have to go to your calculator and graph this function and find out what values of c works here. Put 4c, 4x cubed plus 2x in y1, put a 6 in y2, and then graph and look for an intersection. But we do see that c is 1. Then we can take this c as 1 and plug it right back up here and find f prime of 1, which is 12 times 1 squared plus a 2. That's 14. All right, that's f prime at the c value. Well, we want the inverse derivative at 6, and that's going to be the reciprocal of f prime at 1. So this is 1/14. I know this concept is hard. It's difficult to follow through. It's a tough one, and that's okay. Go back and watch this video again. Watch the video again. Thanks for tuning in.